My name is Saheed Adewumi. I will be talking about this week 4 of our section. We'll be talking about ACE journey, Associate Cloud Engineer journey. So last week we talked about setting up of infrastructure on on the cloud solution. When we are talking about, so this is our agenda. We are talking about Cymbal Superstore use case whereby they are planning to deploy and implement cloud solution. And we are going to be treating some questions and we review study plan. So deploying and implementing Simbator. So these are the key things we are going to be doing in this section: deploy and implement compute engine resources, deploy and implement Google Kubernetes engine resources, deploy and implement Cloud Run and Cloud Function resources, deploy and implementing data solution, and deploy and implementing network resources, and implement resources through infrastructure as code. So all these, they are very important things whenever you are taking AC certification, whenever you are working as a cloud engineer. And the major reason is because after most of the time, this is where the cloud engineer works lies on. And our last week or last 2 weeks section, I talked about
We lost your screen again.
so
Okay.
can how about now?
Yeah, we can see it
And
now.
and
So
you can make full screen slide.
okay.
Perfect.
So um So yeah, we last week we talked about getting basic information about the startup or about a business before you start working as a associate cloud engineer for any project. So yeah, we are planning on deployment, and we for those people that have been joining this call before now, we talk about this the project currently handled by Cymbal Superstore. So we have an e-commerce platform, we have a transportation management cloud solution, and we have supply chain. And we talked about the technology we are planning to use in our last section, Google Kubernetes engine, our compute virtual machine. We have data spanner for our database. We have networking, app load balancer because it is an application, and we have a BigQuery solution. And for the transport management, we are using Relief Pub Subs. We have Compute Cloud Run for Australia, we have data flow for storage, we have Bigtable, and for network, regional network because it's working on within regional. Same to for supply chain, we are working with Compute Engine, which is close to Kubernetes Engine. We are using Data Cloud SQL, and we are using our network internal VPC for backing the database, and we are using regional external HTTP access. So these are the things we have right now, and we are looking into how are we going to deploy all these and the process we are going to take to deploy all this on the cloud infrastructure. So the way to interact. So if you're a cloud engineer, there are different ways that you can interact with your deployments. There is a cloud console whereby you log into your web browser or you're able to open it on your um, any web browser you wish and can able to access it. So it's UI friendly and it's really good for if you're a beginner or if you don't really have experience about cloud, you can use this adibly. So we have command line. So this is more of like a terminal whereby you install Cloud SDK on your system and you run your command there. So this is more of like a intermediary users or developer or engineer. This is really useful because you don't have to do a lot of configuration. You can just write all the prompts in one command line and you can able to run your instruction for deployment. We have programmatically whereby you have to connect some other tools like a Terraform or you use um, like a CI/CD, like a GitHub Action. So these are the programmatic way you can able to do your deployment. But for a beginner, you are able to do this using Cloud Console. So another thing where you can able to learn easily is that instead of whenever you are doing your lab or you are doing your most of these assignments. Don't just copy and paste, which most of the time it is easy to do, but because we are learning, you can just be typing in so that you can know it offhand. So these are the best way you can be able to do. And the best option, the command line and programmatic way are the best option because they are very fast and they give you more stability compared to console. Console is for majorly beginners, I've said earlier. So this is an environment implementing a compute instance. So if you are familiar with, so before I go forward, you just drop it in the chat. How many of us are doing the lab on our own, like practice on our own, and you can able to share your experience on the chat before end of this section, so that we can able to get to review on your experience. So this is an environment where we are setting up our compute agent. As I said earlier in our last section, whereby I was talking about what is compute agent, it's more of like a virtual machine. So virtual machine we have based on the project you want to handle, based on the project requirement, you have to set up your compute agent based on your project. So I have to select on this images. You can see we have the project name, which is required, and we have the region. I have to select the closest region to me, closest zone, and we have the machine type. So we have different type of uh, machine family for the compute engine. If you're developing a let's say web app, web API, you can use general purpose type of machine. If you are using AI compute processor stuff, you can use compute optimize. If you are using memory, like graphics memory require a lot of memory application, you can use memory optimize, or graphics unit, you can use GPU. So this, the higher or the specific requirement depend on the cost. So if you are using general purpose, which is mostly very cheap, you can go for this. But if you are doing something like a streaming, a complicated platform, you can use compute or memory. It depend on the project requirement. And you can able to select the type of configuration you want to work with, which is two virtual CPU and 4 gig RAM and memory. So this is the machine type. You can select all your configuration. We have different type of configuration if you go to documentation. And you have boot disk. Boot disk is the where the operation system works with. So you can able to select the memory disk size, 10 gig minimum, and you can increase based on your requirements. Select the type of operation system we are using. So we'll call it images. So this is Linux, you can use Linux, you can use Windows, depend on the project. And you can give the access IAM, you can assign a service account to this particular instance that can able to have access to it. And you can set up your firewall, which is HTTP or HTTPS, depends on your project requirement. So, and you can do other networking, you can whitelist and you can configure other solutions that will work with your compute instance. So, so this is like, so this is the console way. So this is where you can able to select, drop to. So we are good to go and just create or creating. So, but here we have the CLI, which is command prompt. So you can just able to. So we have this G Cloud. So if you are familiar before you take the exam, you may in a scenario whereby you'll be given prompt and we ask what's the function of this prompt in your exam. So this is the G Cloud SQL instance. So this G Cloud SQL. So this was creating an SQL instance. Create. So you are creating an SQL instance with the name Cymbal Supply Chain DB. So this is the name of the project, and you are assigning the CPU of 8 memory, CPU of 8 and memory of 512 with the region. So this by really you are just creating an instance automatically compared to this process, which is no longer process compared to this. So this is one way. Another way is you can use some serverless technology, which is the top one, using Google function. You can able to declare your instruction. So this they are deployed on cloud one, which is same as CLI. So here we are calling the G Cloud. G Cloud means Google Cloud. So G Cloud function deploy. So the name of the project, and we set up other configuration with it. So these are the basic things you can do as a cloud engineer. You have to have a basic idea of it. It's not really you have to cram it, but as time goes on, you are working with it, you will able to understand the purpose of this. So we have some question here. Um, so these are the reviews technology. I mean the review stop review and study planning. We have uh, deploying and implementing cloud solutions. I've mentioned all these. These are the different resources you can deploy and implement. We have compute engine. We have Google Kubernetes engine. We have cloud function and cloud. We have data solution. We have networking resources and infrastructure as a cloud. As a course, 3.6 deal with Terraform most of the time. The other still follow general convention, which is console or CLI. This this 3.6 always focus on or other platforms that you can use to deploy to optimize your deployment. So, deploying and implementing compute agent resources. So, anytime you are able to want to deploy your platform, you are expect to consider some other major thing, which is launching a cloud compute instance. You have to make sure like which type of disk you are using. So we have different type of disk, so which we are going to visit that soon. The availability, the policy, the access key. So these are the configuration, just configuration of the compute engine. And if you are creating a scaling managed instance group, so a situation whereby you are running application and you have different same projects but different maybe developer mode, tester mode, and production mode. So we have three instances in that scenario, and you may want to configure like have an auto scaling features, some instance template, so you don't have to be creating instance every time. You don't have to set memory. You don't have to set um uh, drive or any configuration you have been setting initially. So you can just use instance template. So if you are using manage instance template, so anytime you are creating another instance, it will be within this template. So you don't have to do everything from scratch. Just use autoscale manage. So this autoscale manage give you the access. Let's say for instance you are running a web app and you can use this autoscale manage instance group and give you the minimum of instance and maximum of instance. So anytime it require you to scale up, this auto scale manage instance will scale up, which is part of the compute engine resources features. And we have OS login. So at times depend on the OS you are using. If you are using Linux, which is the simplest, if you are using Windows or any other OS, we have different type. Another great thing is that you can have your own you can have your own OS and deploy it on the cloud. So it's not compulsory to use open source or images or OS on the platform. So if I mean OS, I mean operation. So we have other configuring VM manager. We have some other tools that make sure that like health check. So this virtual machine manager is one in charge of how your health check of your fees, how to make sure scale up, scale down. So this is the work of the virtual manager. So as a ACE, Associate Cloud Engineer, you are expect to make sure you consider all this before you are starting your deployment processing. So we have a question here. Says Cymbal Superstore says department has a medium size MySQL database. This database include user-defined function. I think let us just keep it. I think by the end of this, we can come back here and be able to have more. So, are you with me?
Yes, we are with you. We can hear you.
S- Okay, okay.
Mhm.
So, so we have the compose engine option. So I've said earlier when we are doing the console, we have this is the machine type. We have different type of machine, and we have based on the processor. So we have the standard, we have memory, we have ICPU, memory optimized, compute optimized, share core, custom. Custom is where you decide okay, to set your own configuration based on the project requirement. And we have the graphics processing unit, which is this NVIDIA processor. So you can able to set up on a compute instance. And there is a solution like Oracle, which is most of the rare virtual machine, you can still set up with compute engine. So we have different type of disk. Whenever you are setting up your compute engine, you are expected to add a disk with it, which is more of like whenever you buy your laptop or your system, you need some storage, hard drive storage. So this serves as hard drive storage, and it's categorized based on their use. We have present disk HDD, and we have SSD, and we have local SSD, and we have RAM disk. So, and everything based on the use case. Whenever you have a high capacity data redundancy, you can use persistent disk HDD or SSD. But because of local SSD is attached to the CPU, so anytime you shut down your CPU compute engine, it will automatically be deleted. So that is why it's advisable, but it's very fast. So this has very high performance because it's already attached with the compute engine. But unlike this persistent disk HDD, there are some scenario whereby you can disconnect your compute engine from the HDD and attach to another HDD in some scenario. So it will just be more of like you are managing your laptop, you can remove an hard drive and connect it to another system. So encryption at rest, meaning whenever they have, if you are trying to access it, be very secure. So all of them are secure at rest by default. And snapshot, whenever you are using the data, they do the backup of what you have been using. So if you are using a virtual machine with your OS, it will be backing it up. So it has capability to be back on your data drive, same to for SSD. But because local SD does not have, it's just for the compute engine does not have, and the RAM disk does not have. So we have bootable. So we have a bootable functionality here, whereby if you are trying to run um, a new OS on it, it still supports. Same thing for SSD. But local disk does not support that, and same thing for this does not have any bootable processing. So use case generally for bulk and storage for the general compute engine, you can able to use persistent disk HDD, and for SSD, just like manual way, SSD is more faster as high input processing system compared to HDD. And we have IOPS for the local drive. It's compared to the persistent disk. This is more high capacity. So in a scenario, let's say for instance, you are using memory cache in your compute engine, or you are trying to do a lot of multi services, you can able to run your local SSD so that it can able to process your uh, file fast compared to this. These are more like a storage. This is more to support the storage, just like a RAM to support the compute engine. And we have low latency and risk of data loss. So most of the time, whenever you delete your data to locally because they are attached directly to the drive, anytime you shut down the instance, you will lose your data. So I think that's the only advantage if you are using persistent disk HDD. It's very stable compared to the RAM and local SSD disk. So I will skip this for now. Um, so we have, let me talk about manage instance. I've said it earlier, whereby deploying instance based on instance template. Sorry, deploying identical instances based on instance template. You have a template and you want to be creating an instance instead of assigning same memory, same hard drive every time. You can just use manage instance group and just use to configure any instance. So you can set as many as you want. So it has the template here and you can use to duplicate any web server you want to run. So instance group can be resized. So instead of dealing with individual uh, individual instance, you can easily manage it from here and it can able to reflect on the instances. Manager ensure all instances are running. So whenever you are setting up your instance management, you can give the minimum instance you are expect to run and maximum instance you are expect to run. So whenever, let's say for instance here we have the instance working and you are already assigned, you have minimum of three you expect it to working. Anytime one of it shut down, the managed instance will automatically create another instance to replace this one that shut down. So it can shut this down and automatically start another one. So this means it's more of working as autoscaler, can be work as a single zone or regional. So it work based on the user request and most of the time. So this is very efficient, especially when you have a lot of instances you are managing as you go, and it will be making sure that the health check everything's in check. So we have a documentation here talking about how we can talk about machine and networking and all other basic things that I was unable to mention about, which is the balancing. You have to understand how those balancing work, auto scaling. So there are some scenario we have different type of auto scaling. We have horizontal and vertical. So at times horizontal means, let's say you are a scenario you are running your virtual machine and it is now lagging behind. Maybe you have used up the memory or you have used up the drive. You can stop it and increase the resources. You can increase the RAM, you can increase the memory, and but because of because of availability of the cloud engineer, you can easily set up it on auto scaling. So anytime it needs the memory, it can stop itself and auto scale itself based on the requirement. So we have the other one, virtual machine, which is talking about the virtual machine. These are the same courses, but more focusing on basic about the compute engine. So this focus on compute engine, which is very crucial thing in our cloud engineer process. So we have the Kubernetes engine resources. This is more of like um, compute engine, but this work with Kubernetes engine. So Google set up its own Kubernetes engine, which we call GKE, which is Google Kubernetes engine. So it works. It has this infrastructure installing and configuring the command line, which for Kubernetes. So Google has this. You can still run if you are familiar with Kubernetes. You can still run whatever you are running on normal Kubernetes platform and still run it on JKE, and it supports other features like Google have some other features unlike native ones whereby you have to do a lot of configuration like autopiloting, regional cluster, private cluster, JK enterprise. So this JKE manage a lot of stuff compared to Kubernetes whereby the developer or the engineer have to be doing everything on its own way. So Kubernetes engine provide this infrastructure. Deploying a containerized application to GKE. So any containerized platform, as we know, Kubernetes is for deploying of containerized application or resources. So this really supports containerized version. So Google just make sure that they provide more infrastructure resources to the Kubernetes on their own platform. So we have further question. We have to skip it too. Uh, so these are the scenario of the Kubernetes API. So you use Kubernetes API to deploy container on a set of node called cluster. So cluster is where you have a lot of nodes, which is more of like instance. So uh, this really has its own advantage, especially whenever you are running microservices platform. So everything resources is going to be managed itself compared to compute engine whereby the developer have to be managing it. So node run containers, each containers we can call this each project and it can able to work. So most of the time it's more of like a microservice and this cluster will be managed by JKE, which is Kubernetes will be able to manage the Kubernetes will be able to manage uh, from the UK, it can able to be managed. So anytime you deploy you use any command of Kubernetes, it can able to deploy and manage the infrastructure. So this control plane is the one managing all the nodes here. It's more of like a master, like deciding the networking features of this cluster. So, and we have some courses here which talk about more of like Kubernetes. Kubernetes is very crucial whenever you are talking about containerized platform or Kubernetes platform. And we have the third one, which is the cloud. Discussed this a lot last session, deploying an application. So this is more of like serverless. So the user don't have to do a lot of things, just focus on your code. So it's used because of the cloud function, we use it for pops up, cloud storage, object change notification, just like once in a while event-based application. You can run cloud run function for. And I will have to skip this. So let us talk about cloud run capability. We have serverless container management. The difference between this and JKE, we have GKE, which is Google Kubernetes Engine, is that you don't have to worry about the confusion about the networking and other things. So this is automated and it's based on service resources. It can scale up, scale down, and that's that like an exposing journal and replicate across zone. It has replica features whereby it makes sure your instance has a read available services for your API or any other application you have. So this is the benefit of using the cloud run capability. So um, function capability, which is serverless function based. So any event that happen, it trigger. Let's say for instance, you are trying to um, maybe get images from the cloud storage. Anytime a user can able to trigger the event, and the cloud run can able to do its work by going to cloud storage and performing auction. So this is an event based and scaled by number of events received. So it's not going to be charging compare. And these are the basic difference between the cloud run and compute engine and GKE. Because compute engine, you have to, as you are setting up the infrastructure, you have to be paying. But you give you full access. You can scale up, scale down by yourself. You can be able to monitor what is going on compared to cloud run. So the flexibility uh is just based on your project requirements. So this is the cloud function resources. We have this. We have if you check it online on Google Cloud Keyboards, you can have all this, and we have the documentation, which is talked about more of a cloud run function. So, the fourth one, we talk about deploying and implementing data source. So, we're deploying our data products like Cloud SQL, Firestore, BigQuery, Spanner, PubSub, Dataflow, Cloud Storage, and AliDB. We have a lot of DB, and the reason why it's very advisable to be using data products is that there are some basic you can set up your compute engine and install a cloud SQL, and install a MySQL on it. It will still work, still give you access, just like you are installing it on your normal system. But there are some basic things like cloud protection, IP, and replica. This backup storage is the most valuable thing about cloud SQL or data solution because they make sure it is easily accessible for your users. So they have replica, they have data backup for your whenever you are having any crash, make some use of tools and export your data without any issue. Compared to Cloud SQL, whereby it's somehow stressful before you can able to export your data. And loading data process. So if you are using the loading data process, you can easily use. We have some tools loading from storage. You can just get from storage and load it directly. So import and export is very easy if you are using data solution compared to setting up on compute engine. So we skip this. And so we have choose storage class. I think we talked about this. So we have two different types. We have structured or unstructured data, which is unstructured. We upload it on storage buckets. But for storage, you use database services. So this is the flow. So anytime you are dealing with database, you use Cloud SQL or Spanner or any of the services, data solution services. So, but for the storage, you can use this. And this was talking about the type of storage within a year. You use archive. Is within 90 days. You use code line. If you will use 30, you use linear storage. And for frequent data, you use storage, standard storage. I don't know if I'm too fast this time around. Let me check my guide.
On the first.
Ah,
From this side, it's not that fast. I don't know the audience, but it's fine
okay,
here. Yeah.
okay, okay. So let's continue then.
Yeah.
So yeah, we have moving forward. So the reason why I'm skipping most of this is that because of our we have a lot of infrastructure. So yeah, setting up a cloud SQL instance. So to SQL instance, you have to create just like we will create a computer engine, same process, but it is more focusing on database parts. So we have the step one, you have to select the instance you have. We have PostgreSQL, we have SQL, different type of create the instance, name the instance, select the database type. Sorry, you have to just create the instance and select the database type, which is SQL, Postgre, or Spanner, depending on the infrastructure database type you are selecting. You put the name, you put the password you are using to access the instance, and set a proper fashion. Select SQL region as done. Select the region, the networking part, and configure the settings. So I think before by the end of this, we can do a little practical here so that we can set up an cloud SQL on our instance. So here we skip the question. So what ways to batch load data into BigQuery? So at times you have a lot of data and you want to move it from the uh let's say you're a data scientist, for instance, and you want to use it for analysis, loading data into BigQuery data, batch predict, offer based performance. At times, you may have a thousands of data you want to deploy. These are the tools you can work with. We have data flow, which can be able to you have ETL, which most of the time you transform your data and load it for you. So, for instance, you are trying to upload a certain set of data. These tools make sure the data in a structured form before it's move it to the BigQuery server before you start your analytics. So this is really useful for a data engineer or data scientist. So it has some other configuration that can help your data structured before you get it to the BigQuery. And we have other ones too, which are uh, CSV, like you can have a data as a JSON. We have different CSV, which is Excel sheets, and other type of file you can upload it to the BigQuery for analysis. And we have SAS as file. So this is a big topic in cloud engineers solution. So there are some process whereby you are trying to migrate on-premise data to the cloud, which is, for instance, thousands of data or a terabyte of data. So this data is very huge that you can't just stream over the internet or over the network. It may have some maybe loss of data or some breaking of data. So you use these services like transfer services, which more of like you migrate it or you use dedicated server to migrate data to the BigQuery. So depend on the scenario, you have to choose the best option. Some use Google hardware to migrate data. Depend on how huge and how valuable the data is. But the general one and popular one is use first two, which is data flow and files where you can upload it to the BigQuery. We have some courses about the storage um, core services. So this talked about the features of the storage of data solution on Google Cloud. And we have some certification badge, some skill badge whereby you can able to set up, deploy an application on Google Cloud, and mostly on Cloud Run, or you can even set up a simple web on JKE. And these are the documentations. So we have the deployments and networking resources. So this talked about the VPC, virtual VPC. Can someone remind you VPC?
VPC.
So virtual process, is it connection or connect? I'm not sure. So this works with this work with we have whenever you are configuring your network, we have custom mode VPC and share VPC. So this give like whenever we have been talking about setting up of instances, setting of JKE, setting up of different infrastructure, all these work together to another work on based on the network. We have custom mode whereby you have your own custom IP and you can able to point it to any instance. And we have creating ingression and exgression. So there are some situations whereby you want uh, your instance to be able to communicate with another resources, but you don't want another resources to be able to communicate. So you can able to configure the IP, the network tag, and you can able to use cloud VPN. So a scenario whereby you use cloud VPN is when uh, virtual private network, whereby let's say you have on premises solution and you are using cloud and you just want to connect with it. So over HTTP, you can use this VPC network to connect with external network. So these are the use of VPC. So VPC to two network, two instance or two VPC network can use it to connect to one another. So these are the benefit of using the cloud networking process. So this has some, if you are familiar with networking, this has some calculation like calculating the number of available IP. They may ask you in your certification exam whereby you are, how many network available for this device, or they want to scale up, what is the expected number of IPs you are. And so you have to do, I think it's 2 raised per n, you have to do the calculation and just there's a tutorial about that on how to do your calculation whenever you are configuring your virtual network. So we have two type of compute engine option. We have auto mode. Auto mode is more of like you are just set it up and Google automatically creates it for you. So Google manage it for you. And we have custom. So this one subnet per region and automatically created. So new subnet added when new region come online. So this is being fully managed by the Google infrastructure and the IP address originated from the. So this has been configured by the system. So you don't have to really worry about this mode. But whenever you are running like a project, like a customized or a sensitive project, you can work with custom whereby whitelist, you can be able to blacklist IP, you can be able to whitelist, you can be able to create subnet and region. So this prefer for production. So these are the two different things. So mostly this two is still secure, but it's just like you have more flexibility control compared to this. And we have the documentation for it, which is virtual machine. We have the foundation, and we have the engine. We have develop your Google uh, Cloud network, which is a skill badge, and you can able to read more about VPC. So in infrastructure as code, infrastructure as a code is more of like we are trying to set up our. You don't want to you don't want to start going to console, you don't want to start going to CLI to do your configuration. You can use some other tools like cloud functional toolkit, which is one of the Google services, and we have config connector, Terraform, which are some of them are third party tools whereby you can able to declare your infrastructure, number of CPU you want to work with, and you can able to deploy. So this is a good example is a Terraform. So you give a Terraform int, which is to initialize Terraform file, to write your plan or the configuration, number of instance you want to turn on, what number of storage data solution you want to turn on, and you have Terraform apply. So apply means of like implement. So this is going to run based on the requirement of your Terraform file. And these are the configuration build infrastructure with Terraform on Google Cloud. And we have the knowledge check whereby it says which data storage is uniquely global available, horizontal scalable database with rational, semantic. So it must be like a spanner because spanner has the global availability. Unlike Cloud SQL focus on zone and region. So if you are trying to, a lot of people are trying to access your cloud, there must be a latency compared to data spanner. Although in terms of the cost, the spanner is more expensive compared to Cloud SQL. So which services are based on logic implement on container? So the first two that's based on it should be Cloud Run and Google Kubernetes Engine because they are work with container. So yeah, they are working with container. Cloud Run work with because anytime you deploy even your app, if you don't containerize, if you don't put it in a Docker, what Cloud Run do is put it on the cloud build, containerize it, then deploy it on Cloud Run. And which is give us that ability of you can able to switch to depend on your container of your application. You can able to switch. And Google Kubernetes Engine focus on containerization. So I think we are end of this section. Before that, I think we can able to do some basic practical and we can able to work around what I've said. So if you are the first time users, you can go to skill Google. So if you have a credit, you can do this. You can able to practice. I want to work within our time. Let me just do this. Please confirm if you can able to see my screen.
Yeah, we can see your screen.
Okay, okay. So for people that want to follow up, so this is the environment. So if you are familiar, because I've been doing some lab, it may not be look the same. So let's compute engine or compute instance. So you see some courses talking about so on compute engine you can use Terraform to deploy, and these are the labs we are using deploy a compute engine remote. So for Windows and Linux you can able to run this. So let me find the one that we can work with, just setting up of a compute engine. Okay, just let us focus on labs. So we have a lab here. This was talking about how we can use and to monitor API Explorer compute engine. Let me get okay. Let us go to the PowerPoint. Okay. Um. Okay. Sorry, this link has been because Google has uploaded their stuff. So let us just stick to this. Deployments. Okay. So and another thing to say like okay, we have Azure, we have AWS, we have other cloud infrastructure, other public cloud provider. So what nice thing about working with cloud infrastructure as a cloud engineer, you are expected to work irrespective of cloud platform, able to work with it. So in this Microsoft to compute engine, Azure, we have this all these have something in common, just that they have different use. So here we use you can able to try this. So also web app. So want to deploy a web app on a compute engine. Do we still have time? Yeah. So okay, I think I can just share the link can you can you can work on it if you are having any uh if you have the time you can able to work on that. So here we have the steps. So in this lab we are creating a compute instance, creating compute instance template. So this template is where you can able to set up, make a configuration, and you can create instance group, create a test and manage group SK. So SK is the one more of like managing your instance, check if one is shutting down, it can able to uh, start another instance instantly. So load balancer check, CDN. So this lab is, I think it's really, this lab is very intense. It's really comprised of what we have been talking about since. And we have a lot of infrastructure, a lot of tasks here we can able to work with. It's because we are running out of the time, but I can share you the link so you can able to work on it. So here we activate it. So these are the steps. The first ones, and the cloud compute, sorry, the compute engine. So enable the compute API just by. So this is running more of on terminal, not on console. Because if you're using console, you have to go to something like this. Uh, uh, you have to able to see something like this. If you are able to, if you are trying to, you can see we have an instant template whereby you can come and do your configuration. So here you can able to set the region. You can set your location if it's global, if it is region, and you can see the cost effects on the right hand side. It's very important so that you can able to work within the project, and you can able to select the instance. So Google give a lot of description about the instance you are picking. The cheapest one, this first two, this and this. The other one, I think, um, so this N1 and N2 are the cheapest one. The other is based on the requirement. And if you are going for compute, are you able to see my screen as you zoom in? I see it.
Yeah, we can see, but Zoom it is better, please.
Okay, okay. So we have the compute version. If you are trying to add graphics processing compute system, you can able to select this. So they are based on their use, and they are giving high performance compute workload. If you are doing computing, you can run this. For memory use, you can use this for high memory storage. You can see the assigned memory based on your project requirement. For storage optimization, you have only this. And for GPU, we have a video where you can able to see, you can able to choose based on the spec of the project you are running, and you can put it on based on the GPU, and you can able to set some storage too. You can able to pick the type of uh, memory, the core memory you're choosing, and you can able to set up your virtual. So anytime you set up your instant template, you do all the configuration. After you create it, you can just start to take instance in this template. You don't have to go through a lot of process. So it will automatically create it based on the template. And we have machine images. So this all your deployments, you can able to see all your OS. You can upload your OS and run it with your virtual machine. So we have these disks. So these disks are the four major one we talked about early. You can create a disk and attach it to a compute engine or an instance or template. So this this give you the to be able to manage your resources. So you can set up a disk and attach to a virtual machine. And we have a data snapshot. Snapshot is really useful whenever your VM crash, you can run back using snapshot to be able to manage it. We have images, which is more of the compute engine. So these are the ones that are available that you can see. It's just so it's able to run and keep it for me. So
Maybe
anytime,
you can zoom your screen a little bit.
okay.
Yeah.
So these are the images that we can able to use to deploy on our platform based on. And if you have already set up an instance before, if you already set up an instance before, you can able to use, if let's say for instance I set up my instance and I have some different images based on the installation, I can able to use it and set it up with another virtual machine. So just back up my OS and install it another instance. So these things are the basic thing, and we have other like the networking tools whereby you can enable your IP, you can do a health check. So for especially for, so these are the major tools. But everything, as I've said, you don't have to know everything at first, but because of based on requirement and practice familiar with the solution. So I think we are almost end of the. Let's see if I have any question. And so anyone with any question? Do you have any question?
Check the comment box.
Okay. So, but this is the lab. If you are trying to just able to access it, you can go with this and able to check the lab. So this is very important because it's just CLI. So not any console, just be doing everything on the terminal, and it's really straightforward. And one thing I do whenever I'm practicing with my lab, I make sure that I'm following, I'm building the instruction, and I'm able to do the process, and I'm able to understand what I'm trying to do, not just copy and paste. And also um, we have this this are the CLI process. So what they are trying to do, are just trying to, this process was just trying to
We can no
deploy.
longer see your screen.
Okay, let me see.
Yeah, it's back now.
Okay, so sorry about that. So this, we are hosting a web app, so you can deploy a simple app if you have an HTML, or if you have a simple application. You can hosting using computation. You can use to host it, or an API. You can use that. So just normal process. Just after you set up your infrastructure, you can log into SSH and able to deploy. Maybe our next section we will do more of like a lab within 30 minutes. We can able to process and able to show how you can able to deploy. Or if you can able to do a help ahead of the time, you can able to just maybe do something and just show it maybe to the community manager, and they can able to review. So this will help us being in line. So the lab is very important. So thank you everyone.